Here we have a SAT math problem. Okay, let's go to the question. In the figure above, line L is tangent to both circles A and B at points P and Q respectively. The radius of circle A is 4 and the radius of circle B is 9. What is the length of line segment PS? Okay, in the given figure, we have to find the length of this line segment PS over here. Now, let me draw radius for both the circles. Okay, let me draw radius for the first circle with the center A. This AP represents the radius of the circle with center A, and let me draw radius for the second circle with center B. This BS represents the radius of the second circle with center B. Okay, now let me connect the centers of the two circles. That is the line segment AB. Okay, at the point of tangency, always the angle between the radius of the circle and the tangent is a right angle. So here we have right angle and here we have right angle. Okay, now let me draw a line segment that is parallel to the line segment PS. So here let me draw a line segment in red color. So this red color line segment is parallel to this line segment PS. Already we know that this line segment PS is perpendicular to the radius of both the circles. Okay, since this line segment PS is perpendicular to the radius of both the circles, the red color line segment I have drawn over here, which is parallel to PS, also must be perpendicular to the radius of both the circles. Then we'll have right angle over here and right angle over here. On this side also we'll have right angle, and let me mark this is point C. Now, let's consider this particular piece of information over here. That is, the radius of circle A is 4 and the radius of circle B is 9. So here the radius AP over here is 4 and the radius SB over here is 9. That is, the length of this line segment is 9. Okay, now let's consider the quadrilateral PSCA over here. In this quadrilateral, at each vertex we have a right angle. Since we have a right angle at each vertex of this quadrilateral, we can consider this quadrilateral PSCA as rectangle. Okay, in a rectangle, opposite sides are parallel and equal in length. Okay, here the side PA, the side AC are opposite sides of this rectangle, so they must be equal in length. So already we know the length of this side PA, then the length of this SC must be 4. Then what is the length of this CB? It must be 5. So that when I add 4 and 5, that is equal to the radius 9. Now let me consider the line segment AB over here, which connects the centers of two circles. Okay, in this line segment AB, this particular part represents the radius of circle A and its length is 4. And this part represents the radius of circle B, its length is 9. Now to get the length of this line segment AB, I have to add the radius of circle A and radius of circle B. That is 4 positive 9 is 13. So that is the length of this line segment AB is 13. Now let me consider the right triangle ABC over here. In this right triangle, this AB is hypotenuse because it is opposite to the right angle, and we have the length of the hypotenuse, that is 13. Okay, now let's consider the other two legs, that is AC and BC. In the other two legs, we have the length for this leg BC, that is 5. Here in this right triangle ABC, we can use Pythagorean theorem to get the length of this leg AC. Okay, now let me write Pythagorean theorem in this right triangle ABC. That is AC square positive BC square equals to AB square. So according to Pythagorean theorem, sum of the squares of two legs is equal to the square of the hypotenuse. So that's what I have written over here. Okay, here I do not know the length of the leg AC, so we can keep this AC as it is, that is AC square. And we have the length for this leg BC, that is 5. We can plug in 5 for this BC, then we get 5 square. And also we have the length of the hypotenuse AB, that is 13. We can plug in 13 for this AB, then I'm getting 13 square. Okay, here AC square positive, the value of this 5 square is 25 and the value of this 13 square is 169. Let me subtract 25 from both sides of this equation. When I do so, this positive 25 negative 25 will cancel out. I am getting AC square on the left side. On the right side, when I simplify this one, I am getting 144. Okay, now to get rid of the exponent 2 over here, we have to take square root on both sides of this equation. Okay, let me do it. Okay, here on the left side, the square root and square will cancel out. Usually when we take square root on both sides of an equation, for this square root, we have to consider positive or negative sign. But here, this AC represents the length of the leg of a right triangle. So the length of leg of a triangle can never be a negative value. So this AC can never have a negative value. So we don't have to consider positive or negative sign over here. We can consider only positive sign. Okay, then we get AC on the left side. On the right side, the square root of 144 is 12. Okay, here I got the length of the leg of this right triangle AC, that is 12. Okay, already we have discussed that this quadrilateral PSCA is a rectangle. In a rectangle, opposite sides are parallel and equal in length. Okay, here this side AC and PS are opposite sides of a rectangle and they must be equal in length. So whatever length we have for AC, the same length I will have for PS. So therefore, the length of the line segment PS is 12 units.